Hello everyone. Today we shall study the last transformation on our trigo function. Alright, so let's begin with the simple sin x function. As I hope you by now have memorized the shape, the numbers on the x-axis. Okay, all these numbers are in degrees, the largest y value and the smallest y value. Alright, and remember the period is 360. The period is the value of x where the curve repeats itself. The amplitude is 1. Okay, amplitude is a distance from the highest point to the axis of curve, or from the lowest point to the axis of curve. And therefore, what is axis of curve? The axis of curve is the line that cuts the graph into half. Okay, today we are going to learn the transformation of the type sin cx, where c is a number. It can be a fraction or decimal or whatsoever. Okay, but we are only going to focus on positive value first. So what is the effect of c inside our trigo function? Now, cx, okay, please note cx is just c, whatever the value is, times x. And this whole thing is inside the sign, alright? So we are changing the shape from inside the function itself. Now, I shall use Desmos to demonstrate the effect of a number attached to x inside the trigo function. Now on the screen here, you see sin x. Okay, the usual graph is from 0 till 360. Now observe what happens when I were to put a number inside the sign. So let me use sin 2x. Okay, a simple example. Okay, now the blue color is sin x, the purple color will be sin 2x. So observe the change. What do you see? Okay, for sin x, we have one complete cycle. When it becomes sin 2x, okay, look at the purple graph. What do you notice? How many complete cycle do you see? Okay, there are 2 complete cycle. Now, what do you think will happen if I were to change this to 3x? How many complete curve, sine curve do you see here? Okay, there are 3 complete curve. If I were to change this to a very large number, let's say 100. Okay, you may not see it, but there are actually 100 complete curve here. Therefore, what is the effect of a number inside our trigo function? Okay, if this was just a normal sin x, there is only one complete curve or one complete cycle from 0 till 360. As we just saw previously, if this becomes 2x, what was the change? The change is there will be 2 complete sine curve from 0 to 360. Now let me show you how it's drawn. Okay, so the effect of 2 is to have 2 of this curve in this interval from 0 to 360. So there will be one complete curve here and another complete curve here. Okay, so there are 2 complete curve, 2 complete sine curve between 0 degrees and 360 degrees. If this was sin x, there's only one complete curve. But if 2 sin x, if it's sin 2x, there'll be 2 complete curve between 0 and 360. Now, if you had paid very close attention to the previous section, you will realize that the amplitude of sine 2x remains 1. Sorry, the highest point remains 1 and the lowest point remains negative 1. Okay? The axis of curve still remain unchanged. It is still the x-axis. The only change of having a number here is just a change in the, if you can observe, it's just a change in the period. Okay? Now recall, what is period? Period is the value of x where the curve repeats itself. Now focus on the blue color curve. As you can see here, there are two complete curves. So where does the blue curve repeat itself? At what value of x does the blue curve repeat? If you look carefully, look at one curve is stopped at 180, then it repeats itself. So the period is now 180 degrees. If you notice, this is simply 360, which was the period. If this was sine x, I just divide by 2. Therefore, the effect of 2 on our sine function is simply that, firstly, there will be two complete sine curve between 0 and 360. Okay? If this was sine x, there's only one complete sine curve. But if it's 2 sine x, there'll be two complete sine curve between 0 and 360. And there is no change to the axis of curve. The axis of curve is still the x-axis. There is no change to the highest and lowest y value. It is still 1 and negative 1. And there is no change to the amplitude. The amplitude remains 1. And lastly, the period will be 360 over 2, which is 180 degrees. So, if I were to generalize this to any value of c, okay, can be fraction or decimal, then the effects are just these two. Okay, there will be c complete sine curve between 0 and 360. As we saw previously, if this was 2, then there will be two complete sine curve between 0 and 360. And the period will be 360 divided by c. Previously, when it was sine 2x, it was 360 over 2. So these are the only two changes caused by having c inside our trigo function. Okay, now let us apply what we have just learned to draw another simple one, sine 3x. Okay, so first we draw the x's. Okay, and our curve, most of the time we always want it to be drawn from 0 until 360. Now, what is the effect of 3? Once again, first effect, there will be 3 complete sine curve between 0 and 360. So let's draw that. Let's draw 3 complete sine curve from 0 to 360. So I'll have 1. Okay, make sure the amplitude is the same. I have another 1. Okay, it's a bit fat there, doesn't matter. And another 1. It must stop at 360 because I want to have 3 complete sine wave between 0 and 360. Okay? The highest and lowest value doesn't change. So this is still 1 and this is still negative 1. And that is how you draw sine 3x. But we are not done yet because what are these values? Okay? What are these values? We have to label everything. Okay, what is even this value here? All the maximum and the minimum. What are their corresponding x values? So I'll show you next. Okay, firstly, what do you think is the period of sine 3x? Okay, the period is simply 360 over 3. Now, this is always 360. Okay, so 360 over 3, so we get 120 degrees. Now, this thing here, okay, where we have 360 divided by the number here, in fact, this applies to all the angles in our graph. So let me demonstrate what I mean. Now, let's say I want to draw sine 3x. Okay, now the first thing you do is you draw a normal sine x graph. Okay, our normal sine x graph. Now, if this was sine x, okay, what are the x values? Okay, let me indicate the one and minus one. If this was sine x, what are the x values? Okay, we all know this is 90, this is 180, this is 270, and this is 360. Okay, so these are our common, common knowledge values. Now, the effect of sine 3x, okay, just like its effect on the period, all these angles will also divide by 3. So this 90 divide by 3, 180 divide by 3, 270 also divide by 3, and 360 divide by 3. So in fact, this has become 30 degrees. This has become 60. This has become 90. And this has become 120. Remember, period is the value of x where the curve repeats itself. So the curve repeats itself at 120 as shown here. But normally we want to draw from 0 till 360. So what do? We know that there are three complete curves between 0 and 360, and we just drew one of them. So we continue drawing the other two. So let us draw the other two. So one will be here, another one. Okay, it'll be slightly compressed, okay, because I have limited space. Okay, it's slightly compressed, okay, but do not worry. I just want to show you how to obtain the angles. Okay, now as we draw previously, sine 3x, there'll be 3 complete wave as shown here. Okay, and we started drawing one complete wave first, and all the angles that we drew for sine x, we just divide by 3. So how about the other angles? How do I draw the other angles? Now notice, from here to here, the increase is 30. From 30 to 60, also 30. 60 to 90, also 30. 90 to 120, also 30. So follow the pattern. So this one will occur at 150 because I just plus 30. And this one will be 180. And just keep on going. 180 plus 30, 210. 210 plus 30, 240. 240 plus 30, 270. 270 plus 30, 300 here. And over here, it will be 330. And finally, it stops at 360 as expected. Okay? Now, let us revise. How do we draw sine 3x? The first thing we do, we draw a normal sine x. Okay? Draw a normal sine x. Alright? And we label the values as if this was our sine x graph. So, memorize them by heart. This is 0, this is 90, this is 180, this is 270, and this is 360. Okay, so that's your first step. Let me write here. Step 1, draw a normal sin x graph. Now, step 2, remember, we want to draw sin 3x. So, the effect of 3 is all the angles I divide by 3. So here, I divide by 3, divide by 3, divide by 3, and divide by 3. And you get the following. Now, most of the time, you are asked to draw this between 0 and 360. Okay? What we just drew is only from 0 to 120, so it's incomplete. So step 3 will be to draw the complete sin 3x graph. Now we know that for sin 3x, there must be 3 complete sine curve between 0 and 360. And we only drew 1. So now we draw the other 2. So draw the other 2 complete sine curve. And you should get something like that. Okay. And we are done. So now we have 3 complete sine curve from 0 until 360. And that is what we want to draw as given in the interval. Now the last and final step, we need to put in the x values for these 2 sine curve here. So how do we do that? Look at the pattern on our first curve. As you can see, the increase from one point to another is 30 degrees. Therefore, if this is 120, then here will be 120 plus 30, which is 150. So keep on adding 30. This is 180. This will be 210. This will be 240. This will be 270. This will be 300. This will be 330. And lastly, as expected, it should be 360. So this is how you draw sin 3x. Besides having 3 complete waves, we must also label all the special angles. Okay, I have listed the steps for you here. So if I want to draw y equal to sin cx, where c is any positive number, okay, we focus on positive first. First thing you do is draw a simple sin x graph over here. Okay, a simple sin x graph. Okay, we all know the special angles 90, 180, 270, 360. After that, you divide all these angles by c, whatever the number is. So, let's say if c was 3, then you divide everything by 3. So, 90 over 3 is 30. Okay, everything divided by 3. Now, if the question tells you to draw between 0 and 360, and we all know, okay, from 0 to 360, there should be c number of complete wave. For example, if this was sin 4x, we all know there should be 4 complete sine curve between 0 and 360. So draw the remaining complete sine curve. Okay, so always see what interval the question gives you. Most of the time is like this. Once you have drawn all the complete sine curves, label all the angles. As shown previously, just see the pattern on the first graph that you draw, and then just continue the pattern. Now, let me just demonstrate what happens if the number is a fraction. For example, half. Okay, how do you think our graph will look like? Now we know if this was 2x, there should be 2 complete sine curve between 0 and 360. If this was sin 3x, there will be 3 complete sine curve between 0 and 360. How do you think a half will look like? So if sin half x, if you follow the reasoning, there should be half a complete sine curve between 0 and 360. How does a half complete sine curve look like? We all know a complete sine curve look like that. So if I want half of it, I just take this one. So for half x, it will look something like this. It's just half a sine curve. Okay? So the angle, so here, if this was sine x, this value is 90. So as we know, all the angles divided by the number, so 90 divided by half will give us 180. Okay, so this is how a half x, sine half x look like. Now, what if I were to draw 1/4 x? Let's be adventurous a bit. How do I draw 1/4 x? Sine of 1/4 x. How will it look like? If this is a complete sine curve, okay, where is the 1/4? Okay, the 1/4 is actually this part here. So it will look something like this. Okay, it will look something like that. Yes, that is how a sine 1/4 x look like. Alright. Okay, the same rules apply to cosine function. Okay, so let's just do a quick one. So the first step, if I want to draw this, okay, if you recall, is to draw a normal cosine function. Okay, draw a normal cosine x graph. So as we all know, it looks like that. Okay, and so just treat this as cosine x and label the values. So this was 90, this is 180, this is 270, and this is 360, 1 and minus 1. Okay, this is the first step. The second step, divide everything by 2. Okay, divide everything by 2. So it will look like this. Okay, now step 3. Let's say I want you to draw this from 0 degrees until 360 degrees. Okay, what we have here is incomplete. And as we know, cosine 2x, there should be 2 complete wave between 0 and 360. Okay, what we just draw is one complete wave. So let's draw another one. So let's draw another one. Make sure it's nice and done. And we know the last point should be at 360. The final step, we need to indicate all these values. So how do we do that? Observe the pattern on our first drawn graph. Here to here, the increase is 45. Here to here, also 45. So everywhere, I need to add by 45. If here is 180, then here will be 180 plus 45, which is 225. So 225 plus 45 will be 270 plus 45, 315, and 315 plus 45 will give you 360 as expected. So this is how so the steps for cosine is the same as for sine. So to summarize, that for the transformation of this following type, okay, as we have been observing from the beginning till now, the effect of C, okay, is simply to squash our curve either inwards or outwards. Okay, remember when we learned y equals to a sine x, the effect of a was to stretch it vertically. So in a similar manner, when we deal with sine cx, our curve will be stretched horizontally. So the effect of C is to either compress it horizontally or stretch it horizontally. So that is the effect of C. Okay, horizontal stretch. It can be a stretch or a compress. Okay, and the only change that C brings to our curve is the period. Okay, the period is, the new period will always be 360 over C, always 360 over C. Everything else remain the same. Our amplitude is still 1, our axis of curve is still the x-axis, okay, and all the angles, as we already saw, all the angles we just divide by C. So that is all for this kind of transformation.